Welcome back, friends, to another video on the art of programming in C++. We're going to, in this video, take a look at another of our control structures. Remember, we have three basic control structures: sequence, branching, and repetition. Now, we've already talked about sequence, that is, one instruction following another, starting from the top going to the bottom. And we will talk about repetition on a later video. For this week, we want to look at branching. That is the ability to control the logical flow of our program. By that I mean, under certain conditions, this set of code will be processed. Under an alternate set of conditions, another set of code will be processed. And that allows us to have decision making in our program. If something is equal to this, if something is less than this, if this condition exists, whatever it might be, it allows us to make a decision either based upon a condition that exists within the program or a decision made by the user. Do you want to continue, yes or no? In order to do that, C++ relies on something called Boolean logic. Boolean logic is the answer to a question. It is a true-false response to a question that says, if this is true, if this is not true. Based upon one of those responses, it's going to direct the flow of our program. And the most basic construct in C++ for handling that is the if-else statement. The if-else statement is really simple. It's easy to understand. It's easy to process. It looks like this. If, and then inside of parentheses, this Boolean expression is true, then process the instruction or the set of instructions that follow that. So if you look at the example right below there, we see if hours, if the variable hours is greater than 40, the overtime rate will be set to 1.5. So very simple to process. Everything goes within the parentheses. We can have simple statements, if hours are greater than 40, or we can have compound statements, if hours are greater than 40 and employee is non-exempt, however that works out. So very simple construct there, but it's very powerful. One thing we need to be aware of is the flow of logic and the necessity to bracket certain things. If I add another instruction after the if statement, C++ is very particular about how it processes things. In the example that we're looking at, if hours is greater than 40, only controls the very next statement. That is, the overtime rate equals 1.5. The instruction over hours equals hours less 40 is not controlled by the if statement. So what that means is if the hours are not greater than 40, it would skip past the overtime rate equals 1.5 and process over hours equals hours less 40 every single time. We fix that by adding curly brackets to the logic. So if I want more than one statement to be controlled by that if statement, then I need to make sure that I curly brace all of the statements that are controlled by that if statement. My habit or my practice when I program is even if there's a single statement, I put curly braces around it. What that does is help me out later on. If I modify the code and go back, I don't have to remember to go back and put braces in. And that helps because this code may be very complex that I insert a change into. If my curly braces are already in place, that's one less thing I have to worry about. So get into a habit of following up your if and else statements with curly braces, even if there's a single set. Now what'll happen, if hours are greater than 40, both of those statements will be processed. If the hours are not greater than 40, the logic will skip past the closing brace and only process the instruction that follows that. Now, there is an else clause to the if statement, and that is it allows me to more specifically control what gets processed when a false response is received to the if question. So if hours are not greater than 40, if they are less than or equal to 40 in this case, then my pay rate gets set to $12.25. Only if they're greater than 40 do I set my overtime rate to $18.38. I know this is a very simple example, but you can more easily trace what's going on here. Okay, so the else clause allows me to control what goes on. If I don't have the else clause there, everything that follows the curly bracket after overtime rate equals 1838 is processed every single time. By adding the else clause, then that pay rate is only processed when the item is false. Now, this makes sense on paper, but it makes more sense when we look at this in code. So what I'm going to do is build an increasingly complex program so that you can see some examples of how this code works in practice. And what we'll do is we'll trace through the code and use the debugger to walk through and see how our logic is jumping around. So let's go to the editor now and have a look at what's going on. All right, in front of us we have a very simple program that uses a very simple initial if clause only. You'll see right here we have if hours are less than or equal to 0, we're going to output an error statement that says that the user gave us an invalid amount. So let's test that out. We'll process the code or execute the code. And as we execute the code, we'll put in 40 hours. We should get nothing. And now let's test it and see if we get an error message. Put 0 in and we get the invalid payroll hours. So logically what happened is that we got the information from the user. We tested the value of in hours that the user provided for us, and it was less than or equal to 0. So the Boolean expression evaluated to 0, or evaluated to true, pardon me. When it evaluated to true, then the statement processed. Now, if you remember from the earlier example, the if statement only controls the first statement that follows it. What that means is that logically, when I process this or I execute this program, what's going to happen is that line that says second statement, this one right here, will be processed every single time we execute the program. I'm going to comment this line out for now, and we'll run the program. And 888, and now we will give it a valid number so that it should skip over our if construct, and you see that the second statement shows up. That's because only this line is controlled by the if statement. So the way that we get around that is we add a second set of curly braces. Open brace, close brace. Now, everything within these braces is controlled by this if statement. So we'll execute the program again, give it a valid number of hours, and you see we get no message this time. So the if clause is controlled by that Boolean expression within the parentheses, and then it processes, if it's true, it processes what is between the curly braces. Now, if we don't put an else clause in here, whatever is immediately past this last curly brace is going to be executed every single time we run the program. So if we want a little more control over program, we will put in, let's see, we'll just put in a message that says valid hours, closing brace, and now we have total control over the flow of our logic here. If they give us an invalid number of hours, that's processed. If they give us a valid number of hours, we are notified as well. So we'll execute this real quick. Okay, 888, we'll go 40 hours, and we see we get the message back that that's 40 hours. So let's just throw a breakpoint in here, and we'll watch it walk through. So 888, 40 hours. All right, so we are here at this breakpoint line. We can see that our in hours amount is 40, and we're going to hit F10. Now, if the hours are less than or equal to 0, we know that that should evaluate to false. So if we understand this correctly, our logical flow will skip this first block of code, come to the else clause, and then process this. And as you can see, that's exactly what it does. Our arrow that tells us where we're executing has jumped down into the else clause and is going to process that. So that's easy enough to trace. The real power of using the if-else clause comes not only in making a simple adjustment in the program flow, that is a conditional branch based on if this is true or if this is false, but the real power comes in being able to nest those structures. So we're going to break for just a second. I'm going to cut the video so you don't have to watch me typing all this in, and when we come back we will look at a nested statement that modifies what we're looking at right here. Okay, through the magic of video, we're back, and now I have nested a second if-else structure within the first one. What this does is it gives me the ability to cascade a number of choices. If this is true, then I can check for a second condition. If that is true, then I can check for a third and fourth and fifth, as deep as I want to go with this logic. In this case, if they continue to give me an invalid number of hours, I will simply give them an error message. But if they give me a valid number of hours, then I'm going to evaluate whether or not I owe this employee overtime. So within the else clause, I have embedded another if-else statement. So I will get the message that says valid hours, and then whether or not I owe that employee overtime. So let's process that again. And we'll give them some overtime. Okay, valid hours, and the message comes back that they're due overtime. Let's test that other branch. 888, and we'll just give them 40 hours. Actually, let's give them 38 hours. And we see we get valid hours, and they are being paid for regular hours only. As I said, you can nest this logic ever so deep as long as it matches the design of your program and addresses the objective of what you're trying to accomplish with your program. The thing that I would caution you about is that when you write a nested if-else statement, make sure that your test plan contains a number of tests that test all of the possible combinations. So if they give us valid hours and they give us valid hours over 40, give us valid hours and they give us valid hours less than or equal to 40, valid hours, whatever the conditions are, make sure that your test plan tests all of the possible branches of your program flow. I think you're going to find the if-else structure a good addition to your coding skills. Good luck with it, and we'll see you in the next video.